Alright, hello. Thank you for checking out my video. And today we're looking at transversal problems with equations. We're building on the lesson about transversals, and today's problems are transversal problems is really similar to my previous video, but it deals with equations. So we talked about how you have an acute angle and another acute angle, and they're the same, so they're equal. Or if you have an obtuse or the obtuse, they're the same, they're equal. But if you have one of each, they add up to equal 180. So you got equal in both of them. Either they equal each other or they equal 180. And once you set that up, you can set up equations. So I'm going to take a look at a couple of problems and show you exactly what I'm talking about. Alright. Okay. So here we've got a transversal, the T. Okay, it goes through two parallel lines, which makes the angle, the two of the angles are the same or equal, one of each equal 180. It makes that true because it's parallel lines. That's only true if you have a transversal going through parallel lines. Now, so let's take a look and see what type of angles we've got. Okay, so we've got an acute angle here, less than 90, and another acute angle here, which makes it both acute angles, so that they're both equal to each other. So what we want to do is find the value of x. So to do that, we're going to set that equation on up. So we'll have 7x plus 3, that first angle, is equal to 8x plus 1. 8x plus 1. And now we just solve the equation like we always done. We want to isolate the variable. Okay, so we got to get them both on the same side, but I'm going to move this number first. So I'm going to subtract 3 on both sides. Bring down my 7x. 3 minus 3 is 0. That's going to be equal to 8x. And opposite signs, different signs, find the difference. 3 minus 1 is 2. Leave it negative. Then I'm going to subtract 8x on both sides. Moving the variable over here. Alright, this will cancel out to be 0. I'm going to bring down to negative 2. And then find the different signs, find the difference. 8 minus 7 is 1, so I have 1x, and it's negative. And then divide by negative 1. X is equal to 2. So you found the value of 2, and that's all you have to do is find the value of x, which is 2. But if you want to take the 2 and plug it in and get that actual measurement, 2 times 7 is 14. 14 plus 3 is 17. This angle is 17. Would this angle be 17? It should be. 8 times 2 is 16. 16 plus 1 is 17. See how that works? So you get the same measurement for both angles because they're equal. So that's how you're able to find out that x is equal to 2. But for these problems, all you got to do is tell me the value of x. Alright, let's take a look at another example. Alright. So on this one, remember, you can't just look at it and just set them equal, because you don't always set them equal. Sometimes you add them and set them equal to 180. You got to stay true to, if they're both the same, they equal. If one is different than the other, then it's 180. So on this angle here, you've got an acute angle, and on this angle here, we've got an obtuse angle. And the same side interior, but again, acute, obtuse, so we know that they add up to equal 180. So that's what we do. We take the first angle, x plus 12, and add it to the second angle, 4x minus 7. And we set them equal to 180. Ooh, that's not good. Alright, so now we just solve it. First thing we want to do is collect like terms. I've got x's here, got constants here, and going to add those together. So I end up with 5x. Different signs, find the difference. 12 minus 7 is 5, equal to 180. And then the next thing we're going to do is we're going to subtract the 5 on both sides. Now it'll give me 5x is equal to 175. And then divide by 5. And x is equal to 35. And that's it. That is using transversals. We'll go back up to the title here. Transversal problems with equations. So you just want to stay true to if they're if you got two acutes, they're equal. Two obtuse, they're equal. One of each, 180. And that's how you set up your equation, just solve. So in my next video, I'm going to go over some more complicated transversal problems, but it's based on the same premise. But for now, I want to thank you for checking out my video. Have a nice day.